on. Percent yield. We have calculated percentages several times throughout the year. What's our generic formula, guys, for any percentage we need to calculate? Something over something times 100. Good guess. Part over whole times 100. Again, write it in your notes so that you have it. Anytime you're asked to calculate a percentage, guys, in any context, whether it's in this class, in a math class, in life in general, part over whole times 100. So my analogy, like I've said, baseball batting average. Part, how many hits you've gotten. Whole, how many at-bats you've had throughout the season. That's how it's calculated. In this case, our part and our whole are these things called actual yield versus theoretical yield. All right, so right here, guys, in your notes, definitions. You've got to know the difference between actual and theoretical. Theoretical, guys, does that mean made up or kind of ideal? What do you think that means? It's the max, right? Like it says, maximum amount. This is calculated, folks, and you've got to write this down in your notes so that you remember this. Theoretical yield is calculated. It's a calculation. It's the maximum amount of product that could form. Do you ever get the theoretical yield, do you think, in real life? No. Meaning every last atom, every last molecule has been reacted with something else to produce the new product. Do you think every single one has ever done that? No, guys, you're not going to get 100% yield. All right, that's the ideal, but some is going to be left in a container. You're not going to get every last molecule. Now, from my experience, I've heard of different reactions getting 99% yield or greater than, but they will never say 100% yield because that would mean every last molecule. In research, specifically in the world of organic chemistry, when they're trying to synthesize new medicines and compounds, if they have anything above a 60% yield, they consider that a great success. They will continue to try to work methods and processes to get it better, but in research, that's considered a big success. Even sometimes 40% is considered. Now, in the world of industry, like Procter & Gamble or Syngenta, do you think they want those low yields like that? Yeah. They want it as close to 100% as possible. What are they all about? Money. They're all about the money, right? All about the Benjamins, as they used to say in the 90s. Do they still say that these days? No? Well, that's a shame. All right.
One more, we say lettuce.
Lettuce? No, you do not.
No, it's bread.
Bread? Oh my gosh. All right. So guys, this one, you will have to calculate the theoretical yield. We've been doing this all along. It's a gram-to-gram problem. Nothing new there for the theoretical yield. We've done that. Now, the actual yield, that's a little bit different. This is the actual amount of product that is formed, guys. It's from a lab result. On Friday, you guys are going to make chalk. All right, chalk. Now, before you get excited thinking you're going to be able to write your name with the chalk that you make, that's not going to happen because, one, we don't have a machine to compress it into a piece of chalk. All right. What? We're making it to see how good of a percentage you actually can get with your lab skills. No, you can't take it home. All right, stay here. But you'll see that, guys. You've got to remember, guys, that it's from a lab result. It's the actual amount that has been produced in a word problem. Folks, in a word problem, this will be given to you. Otherwise, you won't be able to calculate the percent yield. You're not going to get up in the middle of a test and go over to a lab bench and weigh something or mass it out to see how much was actually produced. Now, your lab, we will make the chalk on Friday. You guys are going to let it dry all weekend in the oven. And then on Monday, we will finish the lab to see what your actual percentages are. Again, as we get there on Friday, you actually feel more like actual scientists this week instead of just, playing with water and pennies like we have in the past. Like I said, semester 2, what? No, it's a not like what you're thinking of, an oven. With a burner on top. It's just a little drying oven that we have. All right. Anyway, here's your whole, guys, on the bottom, or on theoretical yield is the whole. Your part is the actual yield. Okay? So you will have to do a gram-to-gram conversion in the problem, and then you'll be given the actual yield, and then the last step is just to put it actual over theoretical times 100 will give you your percent. Here we go. Here's our example. If 75 grams of, what's CO? What's the name of that? Carbon monoxide. If 75 grams of carbon monoxide reacts to produce 68.4 grams of methanol, what is the percent yield? Okay? So, what's the first step we have to do, guys? Let's think about it. We're looking for percent yield. What is that formula? Part over whole. Well, okay, it's part over whole, but what's the part?
Theoretical.
Right, actual over theoretical times 100. So, guys, we need to find two pieces. We need to know what the actual is. Do we know that? Right, it's this right here. That's how much is produced, guys. So our actual yield is 68.4 grams. Theoretical, though, do we know that? That's what we got to look for. How are we going to go about doing that? Doing a gram to gram, folks. So go ahead and take the next minute or two and do the gram to gram process of going from carbon monoxide to CH3OH, which is methanol. What did you say? 79.7%. No, not percent yield. For your theoretical yield. How many grams? 85.8 grams of methanol is what you would have when you do this calculation out. Okay, so that is our theoretical yield. Now, the last step here, guys, we're not done. We've got to now put it into our percent formula, which I'll do up at the top. So we're going to take our actual yield, 68.4 grams. So percent Y equals 68.4 grams actual. On the bottom, we're going to have our theoretical, which is 85.8 grams theoretical, times 100. Our percent yield, Briley, is going to be 79.9%. Now, folks, let's say you made a mistake on your theoretical yield calculation. Let's say you got 90 grams, for just an example. All right? Then you carry that into your percent yield formula, guys. You're not going to lose points in your percent yield calculation because you had the wrong one down here. Okay? You lose a point or two in this calculation, but then you showed me, hey, I know what I'm doing to get percent yield. All right? I know you understand the concept. All right? It was just a math error or something like that that got you wrong. Lots of partial credit can be awarded on this test. That's why you got to show as much work as possible. Easy? Guys, the math is nothing new. The concept is knowing theoretical versus actual, but the math, we've done gram to grams now for a couple weeks. Right? We've done percentages already this year as well. Okay, so nothing brand new here. It's just that application. All right? I want you guys to do one more problem. I want you guys in your textbooks to flip to page 297. I want you to do number 28.